Okay, so in this video, I'm gonna show you guys a UCS that I wrote with regards to this question. This question was posted by John on our Discord server, Woodworking Wizards and Code Crafters Consortium. I'm gonna leave a link, if I can, in the description of this video, so that if you'd like to join this Discord server, if you're not there already, you can join it. And then if you want this UCS, you're probably gonna get it only here, well, at least up until my website is up. So where you'll find it is under the help section, user created standards, and then in the thread, counting parts and adding N of N to description. So the issue he was having, John said, so we have cabinets that get built all the time that end up missing a part or two. The idea to combat this is to assign a part number to each part, as well as a total on the cabinet. Then using those values and add it, saying this is part 1 of 10, let's say, to each part description. This way the builder can verify right on the label that they have everything they need to complete the cabinet. So in this thread, we discuss a bunch of things with regards to limitations we have. You know, there are certain things we can do in CV and certain things we can't really do. It just doesn't have the capability. And one of them is, we went through a few brainstorm ideas here in this thread. One of them was, for example, you can't owner a parameter up, let's say from a part up to cabinet level. An idea to try and get around that is to dim a part, put the parameter on the part, and then owner that part up to the cabinet. But it becomes a bit of a nightmare, especially for what we want to do here. There's just too many parts to do this with, and it means you're gonna clutter your assembly with all sorts of parts, and I think it just becomes a nightmare. So at the end of the day, a suggestion I made was to, possibly the best solution, is to work from cabinet level and dig from there down into the cabinet to count parts. So again, if you can join this Discord server or you're here already, just come and read through this. It might be a good read to see how we were brainstorming a little bit. But let's get right into the UCS. So we're first going to look at this version 1. I've settled with version 2. I think that's the best one between the two. Version 1 is one that could end up extremely lengthy. And I did quite a bit of a write-up in the beginning of this UCS just to explain some things. And then we'll jump into the code. Now, I usually don't make UCS descriptions this long at all, but I'm going to basically just read this out to you, okay? So this UCS will count parts from cabinet level by looking for each part that you include in the UCS. Yes, you have to identify them in the UCS so that we know which parts to go look at and count, okay? As you know, when a cabinet, for example, has a fixed shelf in it, an FS part, it would be something like, this is now the path in the object tree, right? It'll be at cab.interior.fs, okay, which is why I'm saying interior.fs. And the moment it the cabinet gets a second FS part, the second fixed shelf would be interior.fs at 2. Now, in case you did not know, interior.fs is the same thing as interior.fs at 1. And the fact that CV works like that has always been a benefit when it comes to looping through an array of the same parts, such as FS at 1, FS at 2, FS at 3. Reason being because you can have a while do loop run until FS at and whichever index or number you're looking at right now is non-existent. Then you know you've gone through all the FS parts that were placed by the system. And it is also great that you have that if you delete FS at 2, let's say in the case where you have 3 of them, if you delete FS at 2, then FS3 will become FS2. The fact that there is never a gap in the index we'd be running through makes loops such as this work like a charm. Okay, so it's also important to note that I specifically mentioned here parts placed by the system, because in this case of the fixed shelf, that's where it would be located, right? So if you, for example, create a fixed shelf via the new part button, it would typically not be placed under interior. It would rather be a child of the cabinet itself. Okay, so here's an image that points that out. For example, you can see these fixed shelves 1, 2, 3 in here, they were created inside section view the way you're supposed to. So they then get placed by the system inside the interior. They're a child of interior. But when you've used new part to bring one in, that gets placed right under cabinet, becomes a child of cabinet. This can go further than that. There's endless possibilities. If you have a UCS that, for example, creates or dims a part on another part, again, the path is entirely different. So that's what I'm getting at next. So in this particular UCS, I'm going to make sure every part checks under cab for more of itself. But you have to understand that a part could also be dimmed by UCS on another part. A silly example. If a fixed shelf is dimmed on a partition part for some reason, it will be found under interior.pt.fs in the object tree. So depending on what is being done on your particular system, these possibilities are almost endless and would be too many to cover in the code. So again, this UCS is not perfect. Even version 2 is not perfect because you can have these differences, right? Now, a bunch of different methods that went through my head when this request for assistance came up. So one of them was, it would have been easier if a parameter could be owned up to another part. So that's something I mentioned earlier. And then in the UCS code, you could handle them separately and take the count in a loop, similar to what we do in this current UCS, a while do loop, right? You see, if I were to have a UCS doing for each fixed shelf, targeting fixed shelves parts directly, among others, and what I mean by that is, let's say we had others in there as well, right? It wouldn't matter where the fixed shelf would be located in the object tree at all, because it would still be seen, because we're telling the system for each fixed shelf that there is. So that would have been ideal to tackle, to target part level and then send those values up to cabinet level, but it's not something we can do properly. So method 2, this would be cool, is more in the direction of something I would hope might be possible with UCS JavaScript. Although I can't confirm because I don't know JavaScript at all. But if I were to write the concept in UCS macro form, it would look something like this. So we target each cabinet assembly. So what we'll do first is, if this quantity total parameter does not exist, we create it and we give it a value of 0 because nothing's been counted yet. But then right after that, we'll say the value of this parameter is, you could possibly even do that, okay? Quantity total equals cab.parts.count. This might look familiar to anyone doing some Visual Basic or whatever. So this code would assume, if it was possible, that a cab has a field in it called parts, right? That represents a collection or array containing each part. And what I mean by containing each part is because, like, when we dim a new part, let's say, for example, dim fixed shelf as a new part, regardless of its name, it's classified as a part. It's a part we're dimming. So unfortunately, CV doesn't work like this, but it would have been great if we could look at each part in parts and say, like, okay, in this cabinet, in that collection of it, count that. And I still wonder if this is possible already, maybe with UCS JavaScript. But maybe one of the JavaScript guys can confirm this or give it a shot and confirm whether that might be possible. Okay, so how this UCS works before we jump into the code, which is fairly simple. At the beginning of this UCS, we create this quantity total parameter, and we always force it to be 0 initially, okay? This will mean that, unlike what I've explained, or despite what I've explained in that thread on Discord, where you might have a refresh or reset option, you wouldn't need that anymore, because the UCS always starts out by zeroing it out, and after that it counts parts, right? So that means it'll always live update, and this helps when you are, let's say, adding parts. So let's say suddenly you add a fixed shelf to this cabinet, or suddenly you remove one. The count must always stay updated, so that'll be helpful in that regard. And then after that parameter is created and set to 0, that's when we start looking at every part in its original location, which would be, for example, what we've said earlier. Interior is maybe the path where this is lying, cab.interior. but also I'm going to be looking for it as a direct child of cab. And then if it's found, it'll be added to the quantity total. Now, the block of code created for each part is simple enough to copy paste. I did it like that on purpose, and change to a different part name and part path using the count part. Oops, it should be like that. And part path string parameters. Okay, so let's get to the code. Again, this is targeting cab assemblies. So first off, we create this parameter as an integer. We set it to 0. In this case, I've set the style to 1 so that it sits in the sidebar. You can see it. And because I'm doing that, I have to give it a description. So I made it just say total parts. Now, it's fine to have that in the sidebar because remember, because this code's always running, it's always forcing the value and the description of that sidebar attribute called quantity total. So even if someone tries to type in there and they press enter, nothing's going to happen. It's always updating. Okay, so now we get to the block I was talking about. So first one I marked as fixed shelf. Okay, so first thing I do is I create a text parameter called count part, which I say equals fs. Then I say the part path is interior because I'm going to use that. I'm always working from cabinet level, so I'll look at cab dot part path dot what is the part to look at. Okay, so then first off, I create a parameter called quantity underscore. In this case, it'll end up as quantity underscore fs. Okay, I set it to 0 because right now we're assuming there are no fs parts in this cabinet. If this, which is the cabinet, dot, one level down, interior, that's what I said there, dot, the part name, fs, and then I'm looking at its thickness, is not null, which means it exists, it's there. Then I'll proceed to count it, right? But I'm noting here that I'm looking at the part thickness instead of PID. We would typically do this kind of thing looking at PID because the system part would have a PID. And that's exactly the problem here because manually added parts don't have a PID number. But I'd like to include them because we're going to be looking at whether there is one directly a child of the cabinet as well, which would be one that was manually added and it wouldn't have a PID number. So if it finds this, we're going to first count the parts that are placed by the system. First of all, I created a counter integer variable. I just called it C for counter. And I first reset it. I set it to 0, assuming there are none of them. Because remember, that was just a check to see if we find at least one. And if it is there, because remember, the first one would always be .fs, which is also technically at, fs at 1. So once that's found, we just need to see, is there maybe an fs at 2, fs at 3? But what we do is we start straight from fs at 1. So the part index, we're starting at 1. So then I write the little loop that does that. So I say, okay, while this, the cab, at this path, and the part name, which is fs, at, first what's going to happen is it's going to look at 1, because that value is already 1. If its thickness is not nothing, we're going to count 1. But then we're also moving 1 on with the indexing, okay? Then what we'll first do is we'll take this counter that was 0 here, and we add this count to it. Then we quickly, while we're still busy with the same parts, which is still fs, we're still in this loop here, we'll count ones that might be directly under cabinet. So again, we set the counter quickly to 0. We start the index at 1, just in case, because it's on another level. It might be, there might be a, .fs and a fs at 2. So if it finds this directly under the cab, so that's going to be cab.fs, right? At 1 first. If it's not nothing, then we count 1. And we increase the number because it's going to go to the end while and it's going to jump back here. But now it's going to be looking at 2. You know how while do loops work, right? But the while says that only while it finds it does it continue to do this? So by the time all this is run through and it didn't find any extras, it obviously continues with the code. So then here we say, okay, if this value is not still 0 like it is there, because it would remain 0 if none of this happened. So if it is not 0, it means some count happened somewhere. Then we add that to the total that is displayed on the cabinet level. It's actually, this is very simple, a simple block of code. But my problem was now that, yeah, I need to do it for the next part. So what I meant in the description about the block of code being easy enough to copy paste and set up for a different part is because you basically copy that. And then I paste it here and I say in this case, okay, now I'm going to go for partition. And I say that the part is PT, and where is that part located? It's going to be in cab.interior. And then this code is pretty universal. So is this. But you can see, so okay, in this UCS I've only let it do the FS part, the partition, and doors, because doors, I wanted to include them as an example because the path is a little bit different, right? Let's have a look inside a cabinet. Okay, this is a standard tool from the custom cabinets, which has 4 doors, which is probably a good example. So let's go get in here. Okay, so let's go to object tree. I'm going to select the door so it gets highlighted here. Okay, so what happens here is, let's just check in section if this is, okay, so that's a pair door opening, pair door opening. So there's a door opening, a door opening, door opening, door opening. Every door has its own door opening. We can see which ones are where. In fact, let's make this a little bit different so we can see. I'm going to split this one. So now we've got an opening, and a pair door opening. So let's go to ortho view. I'm going to click, let's say this one. Okay, so that door, the only door in that door opening is this one. It says pair door opening, but it's still just a door open, let's call it part. Okay, it's actually opening, but let's call it part, right? Let's open all these. Okay, so if I click this one, okay, that's the next one. Also pair door opening. Then there's single door openings. It says door opening. If I click it, okay, it's that one. And this one is the other one, of course. Now, door opens would also have indexing here because they're falling under the same parent and they have to be identified uniquely. So you can see the first one is door underscore open. Second one is at 2, at 3, at 4. But the door parts, they're just dot door, dot door, dot door, dot door. So I had to cater for this type of scenario as well. Okay, so that's why the code for door was different. I did the same thing. You fill in the same information as you did with the previous code blocks, but this one includes an additional loop. This will run through every index found for the parent path. It's going to look at indexes here, like whether this is at 1 or at 2. Okay. Again, we set our part quantity just to 0 to start off with. Then I'm saying, okay, if while cabinet dot, in this case, face dot door open at 1, because now that's a path index counter, okay? And then I'm looking at PID. I said if it's not nothing, in other words, it does exist, it found one, then it continues. Then we look at what we did earlier. So we look at the path, this time including that path's index over there, dot count part. And in this case, we don't have any indexing happening here, because remember, we saw that door is just .door in every opening. It doesn't have an index. So then we follow the same process. In case door was also added under cabinet directly, we still check that. And then afterwards, again, the same process. We add it to the total. At the very end of the UCS, whatever the last name was would still be contained in this text parameter. In this case, it was door. So I'm deleting that so it doesn't, I don't want to litter in the object tree, right? And then all these values that I kept using, these variables as counters, I just delete them as well so they don't lie around in the object tree. So you can see how this UCS works, but let's look at how this works. Okay, so I'm going to click on cabinet. This UCS is on now. So fixed shelf is 1, correct, because there's 1 fixed shelf. Doors, there's 4, perfect. Partition, there's 0, there are no partitions. And then the part quantity total is the 4 plus the 1, so that's also correct. And what did I do? I've created it as a sidebar attribute, so I can see that. You can also see on cabinet level that my count part string is not here. N, P, and C are not here either. They're deleted, so I've kept this clean. Oops. So there's one I could delete. The last path that was assigned, that string still exists. So if I go and I clean this up as well, that wouldn't exist either. Nice and neat. So because that's a live count, we can stay in section, we can stay in, well, we can keep the object tree open. Let's go in here and go to interior. Let's say we dump a partition in there. Now suddenly the count for partition is 1. The quantity of total parts has increased also. But because it's a live count, it should also deduct it again. You see, partition is back to 0. Now, this was the only other thing. I'd be sitting with a bunch of parameters. So if you want to do that type of cleanup, I could do this. So in this section, oh, that's for doors, sorry. Partition. Let's demonstrate it here. So here it says if it's not nothing, if it's not 0, then you're going to add it to quantity total. If I say here, otherwise, just delete this. Sorry. Okay, now I'm getting rid of it if the count was nothing. So you see now, I'm getting rid of some unwanted or unnecessary parameters. Let's add one in back again. Okay, it's got a quantity of 1 and it adds it to the total. If I delete it again. Good. If I, let's say, add 2 fixed shelves. Fixed shelves have increased, part quantity has increased. Yep. So this works, but you can see that the UCS will get quite long because these code blocks are pretty big. So that takes us to version 2. Okay, so this is version 2. So in this particular UCS, I created the quantity total parameter in the beginning and set it to 0, assuming there are no parts in the cabinet yet. Okay, that's pretty much the same. This will force a value, which means it'll live update. There is a section I labeled as part and path identification, where the user will set up all the parts that need to be looked at and counted. Let me just give you a glimpse of that quickly. It's this area here. This can be seen in the object tree, the paths, I mean, if in doubt. So the user then has to also update the ARR max, which is an array max integer parameter to reflect the amount of parts that were set up in the mentioned section. These are the only things a user should modify in this UCS. They may also change the debug part counter value between 0 and 1 for debugging. So I'll get into that later, but so over here, our array will start to count at 1, and then we tell it that the array max is 3. Why? Because we've got these 3 parts here. So if you were to add another, which we'll get to later, you will increment the number over there. Okay, so as before, we keep creating this this parameter initially being 0. Then we start off, we say, okay, with our array, we're going to start counting at 1. But what is the maximum of this array? It's 3. This should be set to a maximum amount of parts you have set up in the path identification section. Okay, so here we're saying, okay, while the value of ARR is smaller than ARR max plus 1. Why do I say plus 1? Let's say we're going through all three of these parts. We're looking for all three of these parts to count them, right? So let's say we're looking for the partitions. Then we do the count for all the partition parts. At the end of it, we increment 1. We increment ARR by 1. Now the value of ARR is 3. It sees end while, goes back to the top here, but then it reads the condition again, and it says, well, while 3 is smaller than, you see, I didn't want it to say 3. So what it's saying at this point actually is it says, while 3 is smaller than 4, do the following. So then it proceeds, which means I get to check for part 3. But by the time part 3 is checked and done and it gets to here, the code gets to here, now incremented, now it becomes 4. This will say, while 4 is smaller than 4, do the following. But then it sees, okay, well, 4 is not smaller than 4, which means I'm exiting this whole while do loop. I'm continuing from here. I think for a lot of us, we know how this works, but users that are not often using while do loops, I figured let me just explain that a little bit. If ARR equals 1, which it is initially, then the part you're going to be looking at is fs, and it is located in cab.interior. ARR is not 2, so it doesn't do any of this. ARR is not 3, so it doesn't do any of this. So with ARR being 1 and these two having values now, those two strings, it gets to here, and we say again, okay, the path array index, I reset that to 1. We're going to start at 1 to look for at 1 of whatever the path is. So interior at 1. We also use the same part quantity counters as before, just to contain the total of that specific part. But we initially start with 0 again, and then we say while cab dot, what is part path in this case? fs. I'm sorry, interior. So cab dot interior at 1 dot pid. So if it exists, it'll continue to the next thing. Then it checks, okay, cab dot interior at 1 dot fs. If that is also existent, it'll continue here. So this is exactly basically the code used for doors in the version 1 UCS. Okay, so it checks here at the level it should be when the system places it, and then we check for directly under cabinet. And after that, we increase the part path index, which means it jumps back to up here. Now it's going to look at cab.interior at 2.pid. If it doesn't find it, it'll just exit and continue here. If it does find one, it's going to look for other FS parts in that path. So if we continue from here, we say if, in this case, quantity underscore fs is not 0, so it did count some of them, we add it to the total, which at this point at the beginning was 0. So now if it finds one fixed shelf, it counts 1. It adds 1, sorry, to the quantity total. Now this is where my debugging parameter is used. I say if it is 0, then you delete. Just like what I added into version 1 a moment ago. I delete that parameter so that I don't, litter the object tree. However, they are nice to look at, like I demonstrated earlier, if you want to see if the counts are correct. So if you don't want to delete it, then we can just set debug part counter to anything besides 0. I could actually put it to 10 as well, but it makes logical sense to go 1, right? So if I say debug part counter equals 1, it's going to get to here and say if it is 0, I'm deleting, but I don't see it 0, so I'm not deleting this. which helps us to investigate and debug and look and see if this is working fine. After the same code we had as before, it then increments the ARR by 1. So now it becomes 2. So when it gets back here, it says, okay, 2 is not smaller than 4. So I'm going to continue. Then it says, okay, but ARR equals 2. Oh, so the part this time that I have to look at is PT. And where is that located? Oh, in that path. And then it follows through the whole process again. So you can see the amount of code you would have had in the first version versus being able to now just increase this and having one fairly sized block of code handling it for each of these is really cool. Anyway, so now after that whole counting has happened, we say, and this was just a little bit to show how it could be used. In this case, I added it to the cabinet name. So first what I do is I create a text parameter called cab new name, which is text, and I capture the cabinet's description. Then I say, okay, the part count, which is a text string, I'm going to add a space here first, and then a bracket, open parentheses, and then I'll say whatever the total of parts is that we've counted now for this cabinet based on the parts we're looking at. So it says it'll give a number of parts, and then close bracket. Then what I do is I say the cabinet's name now becomes whatever its description was, plus this right next to it, which is a space and that over there. Then I do my cleaning up. I delete the part name, part path like I did before, C, I, and P, which are the numbers I use to do counts. And then again, I use the debug part counter, and I say if that is 0, then delete the array counter and the max array number. But then what I also do is, because that debug part parameter is a parameter created on the cabinet, at this point down here, if I'm not using it, I'm also deleting it, which means I'm still keeping the object tree clean. Let's try this one out as well with cabinets. I'm going to drop a standard tool again. Let's look at the object tree. Okay, so quantity total right now is 5. That is because, remember, we're looking at fixed shelf, partition, and doors. So right now we've got 4 doors and the fixed shelf. So this is something else that I could also clean away at the end. Okay, so what happens here, let's just go back to room level. Let's move this label so you can see it. So the cabinet name is changed to this. Why? Because I'm grabbing the cabinet description and then adding this to it. So if you're not big on using your descriptions, I know at our company we have a description. We actually have a description in our cabinet. Now you can see the description was used here, when in fact when you place this cabinet by default, its name is standard tool. So it'll depend on you whether you want to keep your description to kind of what your cabinet name would be, knowing that you're going to add this to the back of it, but you'll grab from here. The reason I also grab from here is so that I don't have any difficulty in the code, or I don't have to jump through a little bit of hoops to make the code not add bracket 5 parts, bracket 5 parts, bracket 5 parts, bracket to the back of this this cabinet name. Because remember that UCS repeats constantly. So if it executes that code constantly and it keeps adding this to the back of my name, the cabinet name is going to become something ridiculous. Oh, even that is an issue, right? So remember, okay, let's just change that again quickly. I'm going to say standard tool. It should update now. You see, I think this is pretty cool. Now check, we can see the name up here as well. Okay. If I go in here, let's go to the interior. Let's make it simple. Let's add one fixed shelf. You see, the part count and the cabinet name immediately updated. And of course we have, oh, that one hasn't updated. Interesting. Oh, there we go. So that needs a bit of a rebuild to update. But yeah, I think this will be quite useful. So let's go and say, let's look at the object tree to check this out properly. First of all, let me add code to clean up those. Okay, that keeps it nice and clean. So let's say we want to check what happens with this count. Let's use that debug parameter. Let's say put it to 1. If you want, you can go and change the code so that these also get created at cabinet level sidebar attributes or as sidebar attributes. So you don't have to look in the object tree, but I think the object tree is sufficient to look. Okay, so there's four doors, 1 fixed shelf, 0 partitions. In this case, because the debug will only delete this if it's not busy debugging, is fine. But when you have debugging on, I think having this here, even though it has a value of 0, helps you see that, oh, these are the parts I'm looking for in this UCS. So this tells me I do look for partitions, but it didn't find any. Anything that's not listed here are parts you know you haven't put into that UCS yet. Let's make some additions here. Add a partition. Let's add fixed shelves. Let's add another little partition. Okay. So 4 doors, now 3 fixed shelves. Oops. 1, 2, 3 fixed shelves. 2 partitions, 1, 2. Total parts 9. 4, 5, 6, 7, 8, 9. Perfect. And it always updates in the name. Now, just to prove, let's say, let's add a fixed shelf. New part. A fixed shelf, allow UCS modification, important switch. Next, yeah, let's just dump it here next to this cabinet. So you see that part now lies directly under cab. But what happens? It's being counted. So 1, 2, 3, 4. And now this is incremented to 10. So that's great. Let me add. Okay, yeah. Default, sorry. Adjustable shelf. Part count's still the same. Okay, so you find, damn, I haven't added adjustable shelves yet. So let's go and add that. I'll go down to the section here. We'll grab the last bit of code. Let's say, okay, what it's for, I want you to check adjustable shelf. I know that's also sitting in interior. And now we're looking for 4 parts. Close. 11 parts. It's now also checking adjustable shelves. Okay, if I add any, let's change this completely. Let's say 2. Okay, so now we have 2 adjustable shelves. So anyway, I think it should be pretty clear what I've done here. It's not perfect, but maybe it's a good start. And as you see with version 2 of this UCS, I've just simplified the code a lot and tried to make it so that you can easily modify it when adding parts. It's very simple. You just saw how I added the adjustable shelf. So I hope that helps. I've probably over-explained a lot of things in this video, but you guys know me. Even when I reply to or provide answers on Nexus, I like to explain in such a way that if any new user also stumbles across it, that it would make sense to them. And I hope I have succeeded in explaining thoroughly enough in this video. But if any of you came to watch this, thank you for watching. I should try and get into this kind of thing more. Maybe I will once my website launches, but I'm not big on narration. Anyway, guys, thanks for viewing. Enjoy.